All right. So for our forensic project, we chose an exhaust bracket. Okay, so this is the exhaust bracket that broke. And the reason that we chose this is because I actually own my own business and as an ATV and side-by-side outfitter. And this is actually a client of mine that his exhaust broke on there. And so as you can see in the picture, the brake is right above the mounting point on where it mounts to an ATV. At first, thinking, is it mounted on the correct ATV? And we know what it is. The purpose of this bracket is to hold the exhaust onto there.
All right, so obviously the material that was used for this bracket was stainless steel 304. It's approximately, well, it was 0.135-inch thick, and the mix of that stainless steel is 18% chromium and 8% nickel. And the reason that we know that is because we know the supplier, as Jordan was talking about, how it was his business, and so he goes through that Metals Depot supplier.
For the material processing, the bracket was designed in CAD, and it was sheet of 304 was used and was placed onto a water jet table. And the water jet table was used because that way there's no blur and slag, and it's a pretty clean finishing. And the bracket edges are cleaned and a ceramic tumbler.
And then we came to the deducting cause of failure. And so for trying to find out why it failed, we asked ourselves a couple of questions. How old was this product, as age can make a material fatigue more? But this product is only 2 weeks old, so we kind of crossed that out. Who installed it, as installation could also cause damage. And it was an authorized exhaust dealer of ours, so we know that it was installed correctly and that there wasn't any additional damage caused. And what ATV did this go on to, as some racing bikes and performance, heavily performance modified bikes could cause more stress on the exhaust, especially due to heat and stuff like that. But this was on a stock Can-Am Renegade XMR, so there were no more performance modifications. So we knew that there wasn't anything extreme that this bracket was going through.
All right, so while we're asking ourselves those questions, we came up with those 2 causes of failure, potential causes. And obviously the first one is the tensile stress. The limit was exceeded, and we talked about the time period, the location where it broke, and then also the possible weakness when it was designed. And then the second cause of failure was the fatigue stress. And it was actually due because of cyclic loading from the engine. And between those two, we came up with the tensile stress due to the fact that this product was only 2 weeks old.
For the calculations that we did, we found that the yield stress for the material was 31,200 pounds. And doing the calculations with that stress and solving for the load, we found that a load of 6,740 pounds was minimum, and other than that, maximum is going to be a cost to pass the plastic deformation limit. Then we used a factor of safety of 1.2 because the operating conditions are known and the allowable stresses. But using that and the yield stress, we found that the allowable stress is 26,000 psi.
So due to these calculations and everything that we kind of went back behind and thinking about on these brackets, we recommend going to a stainless steel 304 steel, but using a 0.1875 inch thick sheet for the brackets instead, as this will raise the tensile stress enough that it should not break again for any foreseeable circumstance. And it will only raise the cost of each exhaust that uses 2 brackets by $4.78.
And we came up with that thickness, adding 1,000 pounds more to the maximum load, giving us 7,000. And using that and the allowable stress, the new area was 0.3 inches squared, which gives us the thickness of 1875 inches.
So we came to the conclusion that that was the best thing for the redesigning of this bracket, and these are the sources that we used during this process.